Okay, so we have this interesting equation here, and in this video we are not going to be solving this equation by graph, although graphically if you graph this equation, you will notice that from the graph the value for x is 3, but we are not going to be using that approach. So we are going to be using a rigorous algebraic approach involving the Lambert W function. So, and of course, we know that for the Lambert W function, we need to rewrite this equation in such a way that either the left-hand side or right-hand side will appear in this form, so that the Lambert W function or the product log, which is W, can be applied to either the left-hand side or the right-hand side of the equation. So we are going to be applying some rigorous algebraic approach to this equation to just change the form so that the Lambert W function can be applied and then the result can be gotten. So let's start off. So here, I'm going to have log x base 3 equals to 4, then a plus x becomes minus x. And then I'm going to reverse this into its initial form. So we know that 3 raised to power 4 minus x must give me x. So I'll just write it out well. 3 raised to power 4 minus x must be equal to this x here. So it is now an initial equation. And following law of indices, I can rewrite this left-hand side to now become 3 raised to power 4 divided by 3 raised to power x, then equals to x. You know, from laws of indices, if I'm to divide these two, I'm going to pick one base, which is 3, and then I'll subtract the powers 4 and x, which will give me this. So if I evaluate this, I'm still getting this back. So they are the same. So continuing from there, I can cross multiply. So cross multiplying, so 3 raised to power x times x gives me 3 raised to power x dot x equals 3 raised to power 4 times 1 still gives me 3 raised to power 4. And of course, 3 raised to power 4 is 81. And then I still have my 3 raised to power x dot x. So I can, since they are commutative, I can say x times 3 raised to power x is equal to 81. Still the same thing on the left hand side. And I can decide to write my 3 raised to power x in terms of e. In this way, we know that if I decide to write my a in terms of e, I can write it this way. It becomes e raised to power ln of a. They are the same, but I can rewrite this as this. So I'm going to rewrite 3 raised to power x in terms of e. So it's going to be e raised to power ln of 3 raised to power x, because we are trying in this video to rewrite this equation to be in this form, and of course we have to involve e because we have e here. So e has to appear somewhere, either on the left hand side or on the right hand side or on both sides. So I'm going to rewrite 3 raised to power x in terms of e. So let me do that now. So rewriting this value in terms of e gives me e raised to power ln of 3 raised to power x, and of course I still have my dot x there waiting, and equal to 81. And of course I can move this power x to this side following the laws of logarithm. So I have x dot e raised to power x ln of 3 equals 81. And we are getting there. Remember, we are trying our best to see if the number here and the number here will be the same thing. The power and the coefficient will be the same thing. We are not there yet. I just want it to look like this. The power and the coefficient the same. And I want this number here and this one to be the same. So what I'm going to do is I'll first divide the left hand side and right hand side by ln of 3 and see where it leads us to. So divide here by ln of 3 and also divide here by ln of 3. After doing that, I'm going to multiply both sides again by ln of 3 all raised to power 2. So times ln of 3 all raised to power 2 on the right hand side. The same thing here times ln of 3 all raised to the power 2. And then, of course, we know what we're going to do. Ln of 3 cancels one of the ln of 3, remaining one of them. Likewise here too, ln of 3 cancelling one of the ln of 3, remaining one ln of 3 here. So continuing from here, I'll have it in this way. So I have ln of 3 times x, which is x ln of 3 dot, I still have my e raised to the power x ln of 3, and then equals, here I have 81 times ln of 3, 81 ln of 3, and finally I have the number here, which is the power and the coefficients being the same. Yes, so I can, this is what we want, you know, the number here and here are the same. Just likewise the e here, we have x and we have x here. The number here and the number here are the same. Likewise here, the number here and the one here are the same. But I want to try and see if I can do the same thing to the right hand side and see if I can have the same format here. I'll introduce the e in a way and also have the number, the power and the coefficients being the same. So let me rearrange this following another rigorous algebraic approach here. So on the right hand side, since we're done with the left hand side still remains x ln of 3 times e x ln of 3 equals, and here 81 can be written as 3 raised to the power 3 times 3, then times the ln of 3. Yes, if I multiply this to 3 raised to the power 3 is 27 times 3 still gives me 81, so I'm on the right track. And I can rewrite it again as e equals to, this is equal to 3 raised to the power 3 times 3. If you multiply this, 3 times this gives me 3 ln of 3. Then of course still writing this as it was before, or as it is before, 3 dot e x ln of 3. We are satisfied with the left hand side. We are only trying to make the right hand side be in the form of the left hand side, which is this form here. So I can write 3 raised to the power 3 in terms of e again, the same thing I did. Remember that e ln of a is equal to a, so I can write this as e ln of 3 raised to the power 3, then times this one here waiting for us, 3 ln of 3 equal to, I still have my x ln of 3 dot e x ln of 3. Continuing, I can bring this 3 here, so I can write this one first. This is now 3 ln of 3 times, this now becomes e, the 3 comes here, following logarithm, 3 ln of 3 equals, I still have my x ln of 3 dot e x ln of 3. So we are now okay with the right hand side to take a look at this. So we have written the right hand side in this form too. We have our e and we have x, the 3 ln of 3 and 3 ln of 3 being the same, the power and the coefficients here to the same thing, x. So we can now apply the Lambert W function on the right hand side also. So left and right hand side are purely in this form. So let us now apply the Lambert W function on both sides of the equation. So applying the Lambert here, the Lambert W function of x ln of 3 dot e x ln of 3, closing the bracket, equals to applying it here also, the Lambert W function of 3 ln of 3 dot e 3 ln of 3, and closing the bracket. And don't forget, when you apply the Lambert W function in this form, it simplifies to just one of the terms, either the power or the coefficient. So you just bring one of them out. So I'm bringing one of them out here. I'm also bringing one of them out, either this one or this one out. So applying the Lambert evaluates to just either this one or this one. So let me bring one of them out. 3 ln of 3 equals to here, that's x ln of 3. So ln of 3 cancels ln of 3. I just have x equals 3 in the end. So x equals 3 is the key answer to that very equation. So that's it. This is the way you do it if you want to solve using the Lambert W function.